Hello everyone. So in this lecture we'll be seeing fitting of a binomial distribution. So some theoretical values will be given or observed values will be given in our question, and we are going to fit a binomial distribution for those values. So observed values will be given. We are going to find theoretical values for that observed ones, so that these theoretical values will represent a binomial distribution. And the steps in fitting a binomial distribution is given here. First one, based on the given table. The question will be in this format. Okay, table format will be given, frequency and the number will be given. So we are going to find the mean value using that frequency. The formula is summation fx divided by summation f. We know that the mean value of binomial distribution is np. So always this first step is very critical. Okay, so we are going to equate this mean value to np, and p value it can be found by using x bar divided by n. Q, next step we can find it as 1 minus p. After finding p, q and n, we have to write the PMF function, and after writing PMF function we are going to find all the probability values by substituting x equal to 0, 1, 2, etc. up to the last value n. And next one we are going to find, multiply this total n value is nothing but the total frequency, that is total frequency. We are going to multiply the probability with the total frequency. So if we do that, we can get the theoretical value which fits the given observed values to the binomial distribution. So let us proceed. The first question. A set of three similar coins are tossed 100 times. So note that 100 times the throw has been done with the following results. So the number of heads. In 36 times there is no number of heads, and in 40 times we are getting one number of head, and 22 times we are getting two heads, and in 2 times we are getting 3 heads. So we are going to take this one as x and this one as a frequency f. We are going to fit a binomial distribution, and we are going to estimate the expected frequency, or we can name it as theoretical frequency. Okay, and the frequency given in our question, it will be observed frequency. Okay, so let us see the first step. First step is nothing but calculating x bar, that is summation fx divided by summation f. Summation fx, if we multiply both the terms, it will be 0 into 36, which is 36, 1 into 40, which will be 40, 2 into 22, which will be 44, and 3 into 2, which will be 6. If we add everything, it will be 80, 110, 120, and it is, I think so, 126. Now the first one, it will be 0. So clearly here the value is 90. Okay. Now summation xf is 90, and the total frequency, if we add everything, 76, here it is 98, and this will be 100. Total frequency summation f will be 100. We are dividing that using total frequency 100, so our answer will be 0.9. Equating e of x to np, that is 0.9 is equal to n into p. N value, note that we are getting it as 3, because note that x value varies from 0, 1, 2, etc. up to n. So if it starts from 0, the last value is our n. We should not count the total number. If we count the total number of terms given here, it will be of n plus 1, which is wrong. So starting from 0, whatever value it ends with, we are going to take that value as n. So see here, starting with 0, it ends with 3. So n value is 3 for this question. So 3p, and we can find the value of p as 0.3. And third step, finding q, which is nothing but 0.7. And next step, we have to write PMF function, which is 3cx 0.3 the whole power x, 0.7 the whole power 3 minus x into 3 minus x. X varies from 0, 1, 2, 3, etc. So we are next step we are finding the probability values, substituting x values correspondingly we can get this probability value and multiplying this probability value with the n value which is nothing but 100 will be getting 34.3, 44.1, 18.9 and 2.7. Approximating that we will be getting 34, 44, 19, 3. And note that this total value should be equal to 100. That is nothing but total frequency. This is one of the important point in binomial distribution. We can use this trick for verification also. Now let us see the second question. So the number of times 4 coins were tossed and the number of heads has been noted. The experiment is repeated 100 times. So summation f is nothing but 200 already given in the question. And the number of tosses showing 0, 1, 2, 3, 4 are distributed in the table. We are going to fit a binomial distribution to this one. So if you add everything, we will be getting 200 as our total frequency. Now summation fx will be 415, summation f will be 200. If we divide that one, we will be getting the mean value as 2.075. And if we equate that to np, so note that starting from 0 up to 4 it goes, so n value is clearly 4. So equating to 4 we will be getting probability value as 0.5188. So Q value will be 0.4812. Now after that we have to write our PMF function. Writing PMF function we are finding the probability value and after that we are multiplying this with 200. N value is nothing but 200 here. So if you add everything we will be getting 200. So it is 10, 50, 120, 170, 180, 188, 193, it is 199, 200. So we will be getting 200 as our answer. Now let us see the next question. A 6-sided die. So 6-sided die is rolled 5 times per trial. So we are for one trial we are throwing the same die 5 times and the number of times a 6 appears is recorded. Okay, the experiment is repeated for 100 trials. So total frequency should be equal to 100 and the number of sixes it can be. Since we are throwing the dice 5 times, no time 6 may appear, one time it may appear, twice it may appear and up to 5 it may appear. We are going to fit a binomial distribution, the same procedure, summation fx will be 148, summation f will be 100. So our x bar value, that is mean value, will be 1.48. Now equating that to np will be getting, so before that we have to note n value. So starting from 0, the last value is 5. So clearly our n value is 5. So equating that we will be getting p value as 0.296, q will be 0.704 and after that we have to write our probability mass function. We are finding the probability values by substituting x values starting from 0 to 5 and then we are writing the frequency. After approximation we can count that it is 10, 40, 70, 80, 86, 87, 87, 93 and 100. So the total value will be 100 here. Thank you.